All right, so I assume you all saw the Collaborate issue there, or, well, Collaborate issue, and it looks like more of a Blackboard issue. It's being taken down for some sort of maintenance this evening later on, but obviously they got some issues they got to fix. So anyway, we're just going to press ahead. This thing's going to happen on YouTube right now. Wish I could, do it on Collaborate, but not happening. I know a lot of you, too, are still working on the test. I looked this morning, I saw, about whatever, a third to a half still have to do it. So we can't really do a test review tonight either, but we'll knock that out next week after everybody's finished. What we're going to talk about tonight is process strategies. It's actually kind of interesting stuff. I mean, it's things that you already kind of have a basic understanding. For example, if you want to build something simple like a motorcycle, you got to go through a process to get it done. But there's a simple and efficient way, usually, or the most efficient way, a best method to get things done. And it's really focused on the customer, and again, that's the heart of quality stuff. So process strategies, build a production process that meets the customer requirements. So, you could be like a sculptor and do this thing a one-off kind of, motorcycle and build the best motorcycle ever. But if nobody can buy it, then you're not really helping the customer out or yourself out. So, it's got to be able to be done within product specifications. There's a place for custom stuff, and you can also do some customization within a process strategy. But for the most part, folks, want something that can be made, efficiently and well and consistently. And so there's going to be a process strategy. You're used to things like an assembly line or different type things, a job shop, and for different products, there's different strategies that work. So we'll go through and kind of categorize those and explain them. So anyway, jumping right into it. So I talked about a job shop. So say you're printing menus, business cards, and I mean those things have something in common. They're all on some sort of card stock or something else, but the details, the type and everything else on those different products, it's not compatible with a huge high volume kind of thing. It's not like Fritos chips, where you're making Doritos today, and that's all this plant makes, this particular line makes, and that's not the same type of process as a print shop. So a print shop, you can look up there, it's going to say low volume, obviously, and high variety. It's going to do a whole bunch of different products. So it's typically a job shop. And the same with a hospital. You don't typically have assembly lines, although sometimes, if it's elective surgery, hospitals will try and mimic that. They'll try and do all the same type of surgeries maybe on one day for elective type things to get some efficiencies. And then down at that other, and I guess it's only logical we jump down there, or product focused. And again, beer, chips, steel, something that's kind of like a continuous run, high volume, super high volume, but not a lot of low changes in attributes. It's a very common item. And then in the middle there, we have that repetitive. So, motorcycles, stuff like that, where, there's some commonality, but there's also different models, and a lot of times it's modular kind of parts going together. So you have a certain number of inputs, and they come together, and then you can customize that. And then up there at the top, kind of what you would ideally like to have is high volume for a very cheap price. And this has to do high volume, high variety would be mass customization. And that's enabled by something like technology, or really technology. I mean, people, obviously, I've talked about this before. Henry Ford, when the Model T, it was only available in black because that's what was easily done, and that's what would produce a car for a very low price. Well, now, when the customer can essentially generate his own order via the internet or even through a dealership or something, but that can be transferred very efficiently and very focused, and also through the machinery that robots and things like that aren't bothered by little changes. So touching on that too, there's some videos that are out there this week, and again, they're not some of the academic videos that are closed within the lecture are a bit dry, but these ones are actually pretty interesting. And the things that are out there, some of you that are pretty much into tech stuff, you'll already be aware of some of these things. But the one video of how Teslas are built is pretty. That is the standard way it's done. I mean, I've toured the factories in Zuffenhausen over in Germany and Stuttgart for Porsches, and some of the other plants. You go down to Alabama and you see the way Hyundais and Kias and Toyotas and everything else are built. I mean, that is kind of the new normal, which for a country like the U.S. or a country like Germany that has high labor rates and kind of wants to keep high labor rates because they want their employees to be taken care of. It's a way for them to compete, because the labor component, when you're that automated, when you're using that much in the way of robots, is a strategy that's going to enable us to compete. So there's also a network news thing they pick kind of a horrible example for that. I mean, they're putting plastic type things into it. Anyway, but their point is correct that automation and automation, I would say more in the mind of Tesla, is the way that manufacturing is going to come back to nations that have high labor costs. And the jobs, granted there'll be far fewer of them, but they're going to be programmers, they're going to be maintenance jobs that are working on very expensive equipment. And the key, if you are going to do that kind of maintenance work, you want to work on the most expensive equipment possible, because that's where the money is. You work on somebody's beater car, you're not going to get paid well. But you work on a multi-million-dollar robot that, if it's broken, kills production. You can bet that they're going to take care of you and train you well and pay you well and the rest of that, because they want that machinery to produce as advertised. So we're going to run through these one by one. So this was the process focus, so the print shop type thing. General purpose equipment, skilled personnel, high cost, low equipment utilization, product flows may vary consistently. So some of these things, again, a hospital is also, a process focused thing. Let's say you've got some sort of incubator or some sort of, neonatal stuff caring for premature babies. And anyway, you may not use that thing every day, but when you need it, and you are not that concerned with the utilization rate. Well, you can't say, well, we're going to get rid of this piece of equipment because we don't use it very often. And to a lesser extent, that's true in a print shop, but you will find people try and, specialize within a certain item to get the economies of scale and maybe switch to more of a product focus that is, the mass production. But if you're going to be a whatever comes in the door type of print shop, you're going to take on whatever jobs available. You're going to have a wide range of equipment. So this is what they're showing. Again, the hospital there, low volume, high variety. So what they're trying to show on the diagram on the right there is just sort of the fact that the number of inputs come in and they stay semi-uniform, and the number of outputs are also large, and there's no bottlenecking or anything in the process. It's a fairly straightforward process. Well, just keep that chart in mind when we look at other items, because it'll vary a little bit. Repetitive focus. So this is the assembly line that you're kind of used to, organized as assembly lines. I see it right there. Modules. Again, you have different pieces of equipment. You combine them different ways, and you end up with a different product. Less flexible than process focus, but often more efficient. So you can see when comparing these diagrams on the right to the other one, you start out with quite a few inputs, and then it necks down there in the center, and then by the way you combine those items together, you end up with many outputs. I always talk about this in classes being kind of like Mexican food, and people always give me kind of a strange look, but in my mind that's the way it is. You get your basic ingredients, you combine them a different way, and boom, you got a taco, a burrito, whatever. So it's the same sort of thing, modules and a variety of outputs by the different combinations. Product focus, okay, this is going to be high volume, low variety. This again, this may be a Frito plant, but this may just be a Frito, Lay's chip plant, and that's all they do. But by God, they can do it fast and efficiently, because they concentrate on one thing and they do it well. So organized by product, high volume, long continuous production runs, high fixed costs, because you get these machines that, these aren't robots. These aren't flexibility. This thing, will salt chips for you. That's all it will do, but it does it well. But anyway, you buy that kind of specialized equipment, it tends to be expensive. And less skilled labor, again, that's, if you design a process that relies on skilled labor, you kind of pinch yourself in a corner. You create yourself some problems because that labor is going to be expensive. So you want to make things fairly simple. And here you go, with just a certain number of inputs and a semi-wide variety. But, it's the same chips, but we're talking different packages or labeled for different places. If you go to Europe, you'll get the same chips, but they'll be in a foil bag rather than a plastic bag, just so they last longer and things like that. So they're not changing a whole lot of items, just the packaging. And then mass customization. This is, again, what they would have done had they had the ability. Dell being a great example, not really. People will generally still, if the all-in-one computer that maybe has the, the hard drive that's too big or the whatever that I don't need, but the price is cheaper, people are still going to probably gravitate to the big box stores. But the picture that they have there is like a retainer where, rather than have individual dental labs in each town, you could have one of these centralized, and somebody, again, with digital inputs, digital x-rays, digital everything, be able to actually, produce a mass customization. You can think about other examples. There's, silly stuff that's, you go and get Chuck Taylor All-Stars, whatever color you want, whatever combination you want, and 20 years ago, that would have been prohibitively expensive to gather all those inputs and deliver that stuff. Anyway, now it's like, no big deal. It all comes out, electronically processed, digitally constructed, not a problem. So there's mass construction. A lot of inputs, many modules, a lot of outputs. High volume, high variety. And again, they love Dell. And actually, I'm using a Dell tonight. And judging by the way things are performing, whatever. Dell in general. So that's what they're showing, with the mass customization being in the middle. Ideally, that's probably the best process, and that's the way, whatever I was showing you between repetitive focus, process focus, product focus, and you had to choose one. But all the good attributes really come together in mass customization. So if that's available and you can incorporate that, that's something. But don't expect Frito-Lay to, if you want slightly salty chips or something like that, that's probably not going to happen. There's still going to be certain processes that are always going to be perfect for one. So imaginative, fast, rapid, tight schedules, responsive supply chain. Anyway, everything you would look for in an agile supply chain, lean inventories. So how do you go about looking at process analysis and the rest of this? Flowcharts and time function mapping. Again, we talked about this activity on node, activity on arrow. It's all silly. Flowcharts typically are activity on arrow. So, activity on, not arrow, activity on node. I'm not going to even say that word anymore. Time function mapping, we'll talk a little bit more about it, but not a big deal. Value stream mapping is actually, that's a good concept if you look at it in the book. They explain it a little bit, but it's basically looking at everything from the quality or from the perspective of the customer. If I'm the customer and something is done to the product, how does that affect? How does that translate into a benefit for me? And so anything that is done to a product in the manufacturing process, from a value stream mapping perspective, does it add value to the product? Does the product sit in a warehouse for an extra day? Does that add value somehow to the product in the eyes of the customer? No. So that's why it's eliminated. And so if you look at anything that is done with the product from the customer's perspective in terms of value added, you'll by its very nature just simplify the process. So process charts, again, you map things out. A lot of times, like let's say I'm not like a huge fast food guy, but I sound like it in this class, but if you're a Taco Bell kind of person or something where you've got, many outlets out there, it does pay huge dividends to really get down in the weeds and look at every step, necessary in the process of constructing a burrito or a taco or something like that, and getting those numbers as efficient as possible. And service blueprinting, nothing revolutionary. It's just applying those same concepts to a service rather than a product, so you can look at the same thing. So here they're looking at how to assemble a hamburger. Again, this is not going to be like Arctic Roadrunner or somebody like that. This is going to be, somebody fairly large that's going to maybe invest the time and is very concerned with efficiency. And anyway, but they look at how the thing ends up in the broiler, how it goes in the stove, the rest of it, and they assign a time to each process, and they look how long it takes. And one of the attributes, if you are going to a fast food place, is that it is fast. If you're standing there for 20 minutes, you as the customer are not happy, and it's not meeting your specification, basically. So service blueprinting, this is the same type of process analysis, but for a service. So nothing revolutionary here, but you go through and you look at each step. Why is something done, and it's basically justification. And if there's no justification for it, then skip it. There's modify the process, make the process more efficient. Production technology. There's a ton of technology out there that can really enable you to analyze a process, get way down, or not very good English, but down in the weeds in terms of actually tracking a product and seeing what's done. Here they've got an RFID on what looks like a bottle of shampoo. I mean, anyway, the cost of an RFID tag is actually not a big issue. A lot of times you'll see those tags on products in stores, and you'll think it's for shrinkage. People ripping stuff off, but also there's a lot of marketing research. If you get into sort of the big data side, if you're somebody like, say, a Procter & Gamble, you can actually with the right equipment go through and sort of assess how people shop, how they assemble a cart, how everything is done. So in terms of getting truthful and accurate market research, it's pretty powerful. So automatic identification systems, I mentioned a little about that. RFID is pretty powerful. Barcodes are good, but they don't have the power of an RFID where you can scan at a distance. Vision systems, process control type stuff, robots, storage retrieval, automatic guided vehicles. So all this other stuff down at the bottom half of the page, we're not going to split hairs saying what makes a difference between a robot and computer integrated manufacturing system or flexible that's not the important bit. And these guys are a bit behind in technology. Before this stuff was referred to as CAD/CAM, computer-aided design, computer-aided manufacturing, but that's pretty much an obsolete term now because you don't need that distinction between design and manufacturing. You can actually go from the design and straight to manufacturing. But anyway, some of the tools that you saw, for example, the robots on Amazon that can corkscrew and tunnel and do all this pretty intelligent stuff they cross a lot of these lines. And the robot, the one problem I have with that one news video is that their robot's got little eyes. I mean, that's just silly. I mean, they could have that any kind of interface on there. A light just to tell people what's going on. You don't need anyway, I think they kind of trivialize the actual power of robots. Reducing labor costs, so automation. I think I beat that to death here. Lower wage markets. So there's different ways you can go, but I tell you what, the lower wage market thing, it has its drawbacks. Obviously, the logistical chain when you're manufacturing overseas, when you're using overseas talent, when you've got different cultures, you've got many nations that have all sorts of monetary problems where you've got runaway inflation and certain standards of business that we take for granted here, and not just here, as the U.S., but in the high-wage countries that don't exist in these other countries. So automation is not the next big thing. It's already here. But anyway, machine technology, increased precision, productive, flexibility, improved environmental impact. There's probably some aspects to that. Reduced change over time, certainly. Decreased size, reduced power requirements. I mean, those robots, they show them working in factories with all the lights on. If it's a true robot, if it's a completely automated manufacturing facility, the lights are minimal, and it's either too hot or too cold for people, because you don't want people in there. People can get killed by those robots because they're just swinging around. They're not looking at folks. So there's usually a time when people are in the manufacturing facility, and then there's a time when the robots, for lack of a better word, the automated manufacturing equipment is up and running full speed. So automatic identification systems, they're going to run through all these topics again just a little bit more, but RFID is really the powerful one, and you can do this. You can take the entire inventory of a store quite quickly. You can do many things. This SCADA stuff, I kind of get down in the weeds on this just a little bit, but this can be kind of a double-edged sword. In industry and military, and anyway, a lot of different applications, they refer to this as SCADA, Supervisory Control and Acquisition Data. The authors don't use that term, but that's the term that's used in industry. Anyway, SCADA means sort of basically running things by remote control. I was in the Spaten factory, the brewery in Munich last summer, and you go on the brewing floor, and there's not a person there. I mean, it's all done remotely. And here, this is an Anheuser-Busch logo in the background. So it's all fun and games if you're making beer, but if you're controlling a dam, if you're controlling a sewage plant, something like that, all remotely, things can go bad if somebody happens to get in there. And the whole business about a nuclear power plant or a dam being turned loose is probably a bit extreme. There's typically a man in the loop, somebody to prevent that. But there have been occasions. There was a disgruntled guy in Australia who released a whole bunch of sewage, just raw sewage, just by manipulating controls remotely because he was kind of angry at the folks. So it's powerful stuff. It's certainly the way of the future, but the man in the loop business is part of it. This is kind of an interesting thing too, and this is more, granted, read it if you like, but it's kind of down in the weeds. But what happened was the Iranians were building these centrifuges and to enrich uranium, and there was all this drama about what happened was all these centrifuges all basically were destroyed, and it was done by the use of a virus. But what I thought was interesting was the part about these guys on the internet, tell how it was all done, and they didn't have a clue how it was done. I mean, it's come out in unclassified sources now that what they really did was the Iranians were using a specific controller made by Siemens, and they were using that control. It was a governor, a speed control on these centrifuges. And what this particular virus did was it basically removed the governor control, and every one of these centrifuges, spun up to super, super high RPM and basically melted. And anyway, the way they did this, though, was not by taking some sort of virus into the factory or any of that. They put a virus out on the internet in general, but it wasn't a virus that attacked anything but the Siemens computer and the specific application. So any of the virus checkers, none of that stuff would work at all because it didn't care. It doesn't affect anybody's laptop computer. It was completely transparent and viewed as, totally non-malicious. But anyway, after a couple years, since that virus is not being screened or not being detected, sure enough, it works its way over to Iran, and somehow, just by being ubiquitous on the internet, finds its way to these centrifuges, and they all melt. So pretty cool technology. Yeah. Anyway, so they talk about this natty NAS and Stuxnet and the rest of it. Anyway, it was interesting stuff. Vision systems. We talked a little bit about this, on previous lecture. But again, they do fall in the realm of automated systems, and the key thing with this is that a combination, again, a man in the loop. A piece of wood that happens to be the right color would, pass through this inspection system just perfectly. But anyway, the combination would the power of that would be the fact that a vision type system, an automated type system, never bored, modest cost, all the rest of that. So it will get the people to perhaps perform a little bit better, especially if there's a bit of competition between the two. And robots, again, I don't even really like the term robots anymore because, again, they try to portray them as something that walks around and has eyes and all the rest of it. Industrial robots are exactly what you're seeing here. Doing something like welding that's repetitive, semi-dangerous, noisy, there's some gases and stuff being expelled that are probably not too healthy for you. And if you could just, assign those types of tasks to automated equipment and assign the people to doing the engineering, the maintenance, and the programming, it's a better place. So, storage and retrieval systems. I could talk all about this, but I think that Amazon video is pretty powerful. It shows you what can be done, and it's more efficient. Guided vehicles. Again, storage, retrieval, guided vehicles. These things are a lot of times more primitive. Again, it's a forklift. In this case, it's guided probably by some sort of wire or something on the floor, maybe some sort of other guidance system. But the technology will change. But the principle that it's doing materials handling for you. If you've ever driven a forklift in your life, which I did in my younger time, high school, college, and you can destroy an amazing amount of stuff. Hopefully these machines don't do that. Flexible manufacturing system. So, again, they're trying to split hairs here needlessly. It's not that important. It's just, you can see how things are going to evolve. They're going to be integrated, and they can do more and more flexibility. But the big impact from operations management is, and we'll talk about this more when we talk about location strategies, and they'll talk about, things are migrating to lower wage countries. Not necessarily. The automation will bring them back. And the problem when you're going someplace for manufacturing to say a certain low wage country, those countries tend to change. The countries tend to get more affluent. In fact, China now, the wages go up, standard of living goes up, and now all of a sudden they're not the low wage country. And that we started off in Japan post-war, Korea, China. So again, most companies it's not very effective to be moving all the time, chasing low wages. Hopefully automation will be the way. Computer integrated manufacturing, same. Reduces the distinction between low volume, high variety. So yeah, the thing about mass customization and computer integrated manufacturing, it can produce one-off items, totally custom items, cheaply. So that is a huge development. It doesn't require a skilled machinist, It does require some software in there, but usually it's, the software itself is fairly flexible. So they're showing a CAM machine there, computer-aided design. But like I say, it's, this was the stuff we had. Granted, they were punch cards, but we had, CAD CAM when I was in college. So, and they're just showing the rest of it. So not a big deal in terms of the technology. We're not going to teach certain systems, but what we are going to teach is that, the impact of increased automation. So, I think we saw that. Watch the videos. I think they're kind of interesting, especially the Tesla one. I've looked at some of the different manufacturing and some of the different factories, and I've always been kind of a car guy. I was in Europe for a while. I happened to have a Viper at the time, so I've had quite a few friends that had Astons and Ferraris and Lamborghinis and stuff. So I've been most of these factories, and And yeah, everybody thinks that it's, some little Italian craftsman putting these things together, or the German guys, but really it's more automated than you could imagine, and that's really the only way they can compete, even in the the supercar kind of category. All right, so moving on, we're going to talk a little bit about capacity here, and the deal with capacity, it all ties in together, and it goes back to the product life cycle that we talked about before, where you have to do some forecasting. You have to do some capacity forecasting as well to figure out the throughput of of a factory or even a restaurant type thing, because you need to make sure that matches as close as you can predict the demand. You're leaving money on the table if you've got people standing in line waiting for your product or waiting for your service. Additionally, we've all walked into restaurants where there's more wait staff than there are customers. That's not right either. That will kill you in terms of, labor costs. So anyway, capacity is important. So throughput, number of units a facility can hold, receive, store, the rest of that. Determines fixed cost in 3 time horizons. They get kind of wobbly on their time horizons. What they generally agree on and what's used in industry is typically 3 months is, short term. And then 3 out to 3 years is typically medium term, and then over 3 years is a bit longer. So they're called long range, short range. My slides here, the print is not, well, you're going to see the same thing. The slides that I've provided you should be better. But anyway, you can read the text in there a little bit. But the important bit is in long range forecast, you can make some fairly strategic decisions. You can add facilities, you can do stuff like that. Medium, maybe you can subcontract, add some equipment. But when you get a short range, you kind of got to deal with what you're dealt. You can't necessarily, you can add people, but you've all been there, especially if it's a skilled job. Bringing in new people that need to be trained by your most experienced people, that's going to have a negative effect on productivity for the short run. So that may not be the way to do it. And then back to that subcontracting, I've talked about the problems with subcontracting before. A good subcontractor needs to produce the product at the same quality level as your company. They also need to have, if they're going to accept the job, they need to have some excess capacity themselves. They need to be able to take that job on, and probably pretty aggressive in terms of marketing. So the problem for you is that you may be bringing a new competitor. They may not have thought about manufacturing whatever you asked them to manufacture in a small amount, and it's not necessarily greed, but they may decide to, hey, we can do this also. There's room in this market, and we're just going to stay here, and you've got a new competitor. So design and effective capacity. Okay, so design capacity is basically a theoretical capacity. When you're setting something up, let's say a machine will do whatever number of units, running 24/7 with no maintenance, no breaks. It might be able to do that for a couple of days before it breaks, for lack of lubrication, lack of anything. I mean, it's a theoretical production rate. So design capacity is not something that you want to use for, certainly when you're looking at the performance of people who are running the machinery. If they don't achieve design capacity, that's not necessarily a bad thing. But effective capacity, it does include things like normal constraints, normal operating constraints, like shutting the machinery down once in a while to service it, and giving people breaks and doing the rest of that. So it's not just often lower than design capacity, it's going to be lower. I mean, design capacity is the theoretical max output. The two terms they use in association with this is utilization is % of design capacity, and then efficiency is has to do with effective capacity. So again, if you're going to measure people against something, efficiency and effective capacity is what you wanted, the one you want to use, not utilization and design capacity. So here they have a bakery, right? It can do 148,000 rolls, so 150,000 basically was, well, that was the production last week, I'm sorry. Effective capacity, they're saying, is 175, but the design capacity is 12,000 rolls, or 12, can't read anything, 1,200 rolls per hour, working 7 days a week, 3 8-hour shifts, 200,000. So running, full on, and whether it could even make it a week with absolutely no stoppage, it could do 200,000 rolls. So, you compare those three numbers. Effective capacity, 175, so that might be their target. What they actually did was 148, and what the machine could do running flat out is 200,000. So, utilization rate, though, when you compare that, 73.4%, that doesn't look so good. Actually, that's not bad. The efficiency, so measuring against the effective rate, it's 85%. Anyway, a little bit more calculations. That's kind of auto-cycling me on the thing. Okay, so those are the terms that you'll need to know a little bit in terms of effective capacity, design capacity. Does impact, all of the decision. And I kind of related to that. If you come up with a forecast and you come up with an idea of what you're going to produce, and you've got all these other considerations, you need to make sure that you can indeed crank out that capacity. And maintenance is related to this as well, maintenance and reliability, because once you have the equipment that can manufacture these products or bake these rolls in this case, they need to be able to do it without the equipment breaking down. So, capacity considerations, so forecast demand accurately, obviously. Match technology increments to sales volume. So technology increments may be, one machine will do whatever number, a second machine will do double that. What level do you need? What kind of machinery are you going to buy or design? Operating size, there's going to be an optimum based upon your forecast, and then build for change. If machinery, does have the capability to expand, that is something you certainly want to shoot for. So economies of scale, diseconomies of scale. This gets back to, let's say, I think a hotel is probably a better example of this. You get a hotel that's, next to a highway or something like that, and if it only has 20 rooms, that's probably not going to be enough. You're still going to need somebody at the desk. You're still going to need, the lights on in the parking lot. You're still going to need a certain amount of advertising, and you only have 20 rooms to split that cost over. That's probably not very effective. Then again, if you get into, economies of scale, kind of that mid-run, and what they're calling the 2,600-foot store, a medium-sized store in this case, or a medium-sized motel, now you've got, say, 40 rooms. You've got enough rooms to, spread those fixed costs over and probably come up with a more efficient operation. But you can take that too far. You can make, some 80-room hotel that is unsupportable, and half the rooms are empty, but they're still being heated. The linens are still being changed once in a while. The paint is still going to need to be repainted every so often. So anyway, there's economies of scale, diseconomies of scale. Different ways managing demand. You can, if you have too much demand, say you've got that 40-room hotel, the demand exceeds capacity, you can certainly raise the prices. If you're manufacturing a product, you can back order things, but again, that's you're going to lose customers at a certain point. They're either going to feel like they're gouged or they're waiting too long for the product, so that's not necessarily going to work. Capacity exceeds demand. Stimulate the market, so sales, or improve the product. Obviously, you should always improve the product regardless. And adjusting the seasonal demands, this notion of complementary products. Ideal when you can work it out. I mean, you do see it a bit in Alaska, I have a friend who's concrete contractor, and he, they don't do any inside work during the summer months. They only do that during the winter, ideally. They try and schedule all their work for the winter time. And then they do all their outside work in the summer. So they have, a balanced load of folks on there. You see it with the end dumps and all, where they're doing, snow removal in the winter and they're doing dirt work in the summer. So there's ways to work that out. The example they're always going to use is the snow machine versus the jet ski, where the motor is semi the same on each one, and at least the manufacturer is, and they swap it like that. So I don't know why the typeface is getting screwed up like that, but I think you can make out what they're doing. They're showing the jet ski, with a seasonal variation, and then they're showing the snow machine with an opposite variation, and you combine the two, and you end up with a level line in terms of sales and units. Tactics for matching capacity demand. So staffing changes. The problem with doing that, you start messing with the HR element, with the people, and that's a little more difficult. The estimations in terms of the amount of money you spend training and retraining people, hiring and firing people, you're often going to underestimate it. It's usually easier to maneuver equipment around or stimulate demand, do something else, but the hiring and firing business is often quite costly and difficult to assess. Improving the process throughput, obviously you would do that in any case if you can. Redesigning products to facilitate, again, that's kind of a no-brainer. You should be doing that regardless of demand. And closing facilities, again, you get back in the HR element, so that's difficult. So service sector demand, capacity management. So again, we'll talk a little bit about these different items in detail. Capacity manager, full-time, temporary, part-time staff. Again, some of the staffing decisions are being made now are being made by artificiality, such as healthcare. People who work more than a 30-hour week, are subject to the employer providing healthcare. So some of these decisions don't actually fit within the operations management realm in terms of the rationale for some of those decisions, but you can make them, and based upon the staffing. Bottleneck analysis and capacity analysis. Capacity analysis obviously is measuring the throughput and seeing how machinery can be aligned to work that out. A bottleneck is basically the limb fact within a production facility. If you've got one machine that is, the slow output, the place where things are always backing up. I think we understanding what a bottleneck is kind of common sense to figure out. The thing with a bottleneck, though, is if you make any improvements anywhere else in the process other than the bottleneck, you're kind of fooling yourself, because the bottleneck is always going to be the thing that the item that's going to come back as being the one item in the production line that takes the longest. Throughput times, same as we go, and then capacity analysis. Again, it all gets back to process analysis, assigning each process, evaluating it, doing the comparison. Inherently, a process that's parallel like this is going to give you a little bit more flexibility rather than, one large assembly line. Two parallel assembly lines is usually the better means. Here they show the math for the items, but again, I'm not going to wrap up too much in this detail. It's fairly self-evident if you look at the numbers. Can be used for services or making a product, as in the previous example. So again, if you want to truly know how a dental operation is working, this is the amount of evaluation you'll need to do. You're going to need to get down in the weeds to assess. The theory of constraints. Identify the constraints, develop a plan, focus resources, and go back to step 1 and overcome. So bottleneck management, base the bottleneck. Drum, buffer, and rope. We'll talk a little bit about that, but again, it's explained a bit in the book. But the big picture with bottleneck management is that the actual bottleneck needs to be addressed. Increasing the capacity of non-bottleneck station is a mirage, is what they say here, and that really is the case. If you have a production process that's being slowed by a certain process in the line, it's quite obvious that changing any other aspect of the line until you've addressed the bottleneck is not helpful. Break-even analysis. So break-even analysis will give us a certain point. On these ones, because some of the models I would prefer that we actually do this and collaborate. So let's see how far in the weeds they get in on break-even analysis. Well, we'll run through what they've got here. Break-even analysis. This is what I was getting to with the sort of the hotel example where I was talking about economies, diseconomies of scale. If you've got a hotel, there's certain items, depreciation, taxes, debt, mortgage payments, all that stuff on the hotel. Those are going to be fixed costs. And then you've got these variable costs that are going to change in relation to, in this case, the number of guests staying there, which is going to translate into labor in terms of housekeeping, materials in terms of laundry, soap, and other things that are used, consumption of utilities from the guests, and a contribution is the difference between the selling price and the variable costs. So the contribution is when you come up with all those variable costs, and we'll talk more about this in terms of yield management and sort of the either the hot wire or price line type model where they'll sell something for a much lower price, but it still covers some variable costs, so they're willing to sell it at a lower price. Anyway, that complex or that concept that deserves its own explanation, its own videos to support it, but we'll spend some time on that. But break-even analysis. You go through the revenue function, begins at the origin, proceeds upward to the right, increasing the selling price. Where the revenue function crosses the total cost, that's the break-even line. Now you're in business, right? Your goal is not to break even. If you're only break even, then why did you get involved here? So the goal is to march things as far to the right as possible. You get off here in the profit corridor, that's where you want to be. Achieving break-even is good, but you as management most of the time aren't even being paid until you exceed that. So you're going to get as far to the right as possible. And how do you do that? The fixed costs need to be covered, and then the variable costs, which is where the contribution rate lies, we'll raise that. Break-even analysis, costs and revenues are linear, which they're not always. So you need to, again, know your specific situation, know the cost. Yes, they can be difficult to verify, and time value of money is often ignored. So, $5 today is not the same as $5 a year from now. Break-even point in dollars, the price. So anyway, it becomes a simple calculation. For these formulas, if they're necessary for the final or the next exam, they'll either be printed on the final or you'll be given a list of formulas that you'll need to memorize. So don't worry about memorizing these specifically, but you can kind of figure it out. Fixed costs on the break-even point there, fixed costs divided by the price minus variable cost is going to give you that break-even point. So it's fairly straightforward if you look at it. Again, you can increase the math, and then you can also. It's always easier to work when you're plugging in regular numbers to make it a little bit more concrete. But anyway, so selling price is $4. Material is actually 75 cents. Direct labor is $1.50. So that's 75 and 4. Your fixed costs were 10,000. So anyway, just per the formula, come out with an answer of a break-even point of 57.14. So again, fairly simple math. But again, achieving break-even point is not the goal in business. Getting far off to the right is the goal. And then, obviously, any manufacturing or realistic example is going to be a multi-product example. So just a summation. So you just basically stack up these equations next to each other. Not that much more complex. All right. So as we come to the end of it, the homework is going to be just as written there. Matthew Bailey CAD software. The video one, again, don't get too wrapped up. I mean, I want you to, first off, the video comments, you don't have to put that much thought into them. They sort of fill an attendance square, and they're only 1 point. But when you're looking at those videos, try and come up with other applications that you could think of. You're going to see more and more in the realm of services, more and more automation. There's, many services now where, often now you'll go into one of the banks and you'll see no line at the teller, but you'll see a line at the ATM. And the same is true in the grocery stores. You'll see people at the automated checkout. There'll be a line, but no line for the actual cashiers. So people do tend to gravitate to that for some reason, and you're going to see more and more in terms of services. And if you are in service where it is actual people contact, you need to make sure that there's some value added. There's a reason why somebody wants to interact with you rather than a computer. So that's kind of the takeaway from that. Next week we'll review the test. Again, I'll have this thing posted, but hopefully by the time you guys see this, you'll all have taken the test. And good luck.